Now let's start working on the second check, where we have to find the standard error of estimate, and we have to check that 95% of our values does it fall within the plus minus 2 standard error of estimate. So let's start working on that. At first, I have written the equation that we got when we plotted the graph in Excel, and now let's write it in this format here, which is y is equal to a0 plus a1x. So that would be a0 is minus 12.564 plus 6434.9 x. Now we know, according to our values of time and amplitude, this is our amplitude and this is our time. So if we rewrite it, we have amplitude is equal to minus 12.564 plus 6434.9 t. Okay, now we know that this is our a0 and this is our a1, so you can write those values separately if you want. Now we have to find out the standard error estimate, so we have to start working with this equation here now, and let me write down the points, the data points that were given to us in a table first. So here we have the TI, and then we have the amplitudes, and then we have a0 plus a1 times t I, and then we'll find out the residual, or just let me write it a bit closer. We'll find out the residual, and then we will square the residual squared. So this is all to find out the standard error estimate, which is let me write the formula somewhere so you have it in mind. So here we have standard error estimate of a given t here, and the formula looks something like this: square root of SR divided by n minus 2. And then for SR, to find it out, we have to take the summation of I is equal to 1 till n, and then we will take our AI minus, we will subtract the a0 plus a1 times t and square that. So square, we'll take these values here, square each, and take the total sum, and we'll get SR or S sub R. So that's why we need to work on our a0 plus a1 times t values here, and then the residual, which is ai minus a0 plus a1 times t. So this entire thing is the residual, and then the residual squared is when you do the squared also, right? Okay, so here we start with the TI. From the slides we had the data points. Let us write them down. So we have here 0.001667, and then we have 0.00183339, and then we have 0.0020007, then we have 0.0021667 and 4, then we have 0.00233 1. The AI values given to us for these time data are minus 2.0832, then we have minus 1.1256, and then we have 1.9474, and we have 0.18377 here, and then we have 2.6264. Okay, now we will work out the formula for A0 plus A1 times T. So you already know the value of A0 plus A1 times T. So just for the timing, I'll write it down here, but then I'll erase it later on. So for A0 plus A1 times Ti, so A0 is minus 12.564 plus A1 is 6434.9 times Ti. So every time we'll put in the different Ti's from here, it will change all the time for each value we derive, and this will give us all the numbers that we are supposed to receive for this column here. So we'll have here minus 1.8357, and then we have minus 0.7630, and then we'll have 0.3103 and 1.3830, and the last one is 2.4557. Okay, now for the residual, as I told you, is the amplitude minus these values that we just derived here, A0 plus A1 times T, right? So the residual is this part here. So for that, we'll take the AI values from here and subtract these values here, right? So that will give us minus 0.2475 minus 0.3626, then we have 1.6371 minus 1.1992, and here we have 0.1707. and now we just square it, the residuals, and that will give us the values here, 0.0613, then we have 0.1315, then we'll have 2.6801 and 1.4381 and 0.0291, right? Now to calculate the S sub R, we need to sum all the values of the residual, right? So we need the summation of all of the residual squared, and that is 4.3401. Okay, so now we have the S sub R, then we can find out S sub A given T, the standard error estimate. So let's start working on that now. I'll erase this work here. So okay, so now we have here, let me write so that you can see them later. So we have S sub r is the summation from I is equal to 0 until n. We have AI minus A0, which is minus 12.564 plus 6434.9 times TI squared. So this value here is equal to 4.3401. Okay, now we have to find out the S sub A given T. So that is equal to square root of S sub R divided by n minus 2. So we have here S sub R is 4.3401 and divided by our n, the number of data points that we have are 5 minus 2 here. So this gives you the value 1.2028. Now, once we got this, we need to find out the scaled residuals. So we need to find out the scaled residuals. The formula to which is residuals divided by the S sub A given T. Okay, now if I write that here, so let me write it here, the scaled residuals so the values are, so we take the residual number, which is minus 0.2475, and divide it by this new number that we got for the standard error, which is 1.2028. So this will give us the value minus 0.2058 minus 0.3015, 1.3611 minus 0.9970, then we have 1.1419. Okay, now we are supposed to check this scaled residuals if 95% of these values of the scaled residuals fall within the plus minus 2 standard error of estimate, right? So let's check. So we have minus 0.2 something. This is between or you can say below or more than minus 2, and here we have the next number is still more than minus 2, and here we have 1.36, which is less than 2, and here we have minus 0.9 more than minus 2, and here we have 1.14, which is less than 2. So all these numbers here in the scale residuals, all these numbers here are between plus minus 2, right? So we can say that in this case 100% of the scaled residuals are between plus minus 2, or you can say more elaborately between minus 2 and 2. So this is adequate, so you can say this is adequate. That's the end of second check.